Write the big word function on your paper. And I'll see if I can explain this in the worst possible way here. What is a function, you ask? The exact definition of a function. First of all, it kind of boils down to this. Okay, let's look at a general linear equation. Y equals 2x plus 3, right? Now, we're not going to necessarily graph it right now, but we are. A lot of times when we first started doing this, we started making tables, correct? Of x and y values, where you got to pick the x value and you got some sort of a y value, right? You with me on this? So if x was 0, y was 3. If x is 1, y is, jump in here anytime, x is 2, 7. If x was negative 2, what would y be?
Negative 1.
Ooh, negative 1, we're good. Okay, now, with that being said, here's the deal. This one here, the dependent, or the independent variable, the x values are what we call the domain. Get that in your head. Also called the independent variable, because you got to pick. You get to pick the x values. Okay? The y values are what we call the range values. I don't know who made all this up, but I just have to give it to you the way it is. Okay, they're called the dependent. Is that E-N-T?
A-N-T.
Are you sure?
I do not know.
Alright, well then don't say for sure. Alright, why? Because they depend on y. Or they depend on x values. X don't depend on anything, you get to pick your x values. But these are dependent because they depend on x. The domain is independent, range is independent. Now before we talk about a function, we have to talk about what the book calls a relation. Speaking of dances. What was the dance? Scale of 1 to 10?
9.
Oof. Wow, savage.
Middle school, how good can it be?
Had a slow start but a big finish?
Dude, we're writing on tables to start.
That was cool.
Better leave that.
I
Highlighters.
had a lot of fun.
Yeah,
There's
no.
one that's our
Okay.
highlighters.
A relation. We have to go with the definition of this here. A relation is this, and this is right out of the book if you're following along on lesson number 24. I don't care if you do or not. It's a set of ordered pairs. Set of ordered pairs. And hopefully you know that these are ordered pairs. Matter of fact, I could write them down. If we're graphing them, we put 0, 3 as an order as a pair. 1, 5, 2, 7, and negative 2, negative 1. A relation is a set of ordered pairs where, listen very carefully to this, each number in the domain where every number in the domain is, does it say mapped? Is that the word they use? Matched. Is matched to one or more numbers in the range. We'll let that sink in for a minute. If we take that apart, what that means is this. Sometimes we show this in table form, sometimes we show this in a mapping form. This is what it looks like in mapping form. You have your two little circles here. 0 gets mapped to the number 3. This, by the way, is the domain. This is the range. 1 gets mapped to the number 5. 2 gets mapped to the number 7. And negative 2 gets mapped to negative 1. This, ladies and gentlemen, is a relation because the only thing a relation has to fit the requirements of is that every number in the domain, which is this, gets mapped or goes to one or more numbers in the range. Now what could happen in a relation is this. 1 could not only stand for 5, but it could also stand for negative 5. Correct? 2 could also stand for 7. It can go to, as long as it has at least one or more, it is a relation. Now you ask, what would fit that bill if I were writing an equation?
What would fit that bill if I were writing an equation?
What would fit that bill if I was writing an equation?
How does 1 also match with negative 5?
Well, let's talk about that. Now you don't have to ask why, it just does.
Okay.
I mean, it can. But if you had this equation, y equals the square root of x. You remember the graphing of this, or let's do this in a mapping, by the way. Let's do it like this, just so you can see it. It's the same thing as making a table, but sometimes the book chooses to do this. This is your domain, which is also your x. This is your y, which is also your range. What happens here if x is 4? What is the square root of 4 technically?
2.
And?
Negative 2.
Right. 2 and negative 2. You know, if you had 9, you would get 3 and negative 3. Which you should say, hey, what would the graph of that look like? Say it, Savage.
That was 2 and negative.
What does the graph of y equals the square root of x look like? Let's pick some numbers. Let's just do 0. Let's do it actually as a table, x and y. If x is 0, y is
0.
0. We're good with that. 0, 0. If x is 4, 1, 2, 3, 4, y is what?
2 and negative 2.
2 and negative 2. So here is what? 1, 2, 3, 4, 1, 2, and negative 2? If x is, what's my next one?
9.
I guess I should have done 1. If x is 1, it's what? 1 and negative 1. Here's x is 1. It's y is 1. Y is negative 1. Right?
Yes.
So if you're actually graphing that, it looks to be, it's going to do something like this. Got that?
Yes.
Perfect. Now, here is, the reason we went through all that is because we are talking today about functions. Functions are a specific relation where here's the kicker on this. Every value in the domain has one and only one value, or paired with one value, it's paired with in the range. Which you say, what?
What?
I'm gonna let you write that down first. Let you write that down first. Something's not right about my square root of x. I don't know why. Think about that in a minute. Okay, which means this, children, understand what this says. This says this, if you have, I'm going to give you two examples here. Here's our mapping of my domain and my range. Let's say I have 1, 2, 3, 4, and I have 3, 4, 5, 6, and it doesn't matter, Tyler, how I got this. It doesn't matter that you can't come up with the equation that this works for. The rule for a function is that off of every domain, you only get one arrow coming off of it. It can't be mapped to two separate ranges. Okay? So you're just looking at the domain. 4 equals 6, 3 equals 5, 2 equals 4, 1 equals 3. 1 cannot equal 3 and 4. It can't go to 2, it has to only go to 1. Again, you don't care why or how it ended up that way. You don't need to know the equations. You only need to know that off one domain gets only one range. That's all you need to know. Okay, don't let everything else muck your water. You're looking for just one thing going to one thing. Evelyn, what was your question on that?
Can you read that last line?
The value it is paired with in the range. Paired with in the range. So don't concern yourself about where those numbers came from, just concern yourself about what it looks like. So this is a function. Looking at another one. Let's say I've got 0 and 3, and I have 5, 6, and 7. 0 goes to 5, 0 goes to 6, 3 goes to 7. This is not a function because one thing in the domain gives you two things in the range. Got it? There are two arrows coming off of one of the numbers. That can't happen. This is not a function. It cannot have that. Just know that. Yes, Abram.
How would you graph?
We're not worried about graphing. And that's one of the problems with functions. You can't. I mean, you could get. These would just be different dots right there. Yes.
The one that we did with square roots is that's not a function because it goes to more than 2 or more than 1.
Yeah. Now, take a look at this because this is where people get confused. Ready? You might want to clear your minds. 0, 1, 2, 3, 4. Function, yes or no?
Yes.
Yes.
Westfall? Function, yes or no? Reading the strict rule of what it says there, you just ask yourself, does every value in the domain just go to one value in the range? In other words, is there just one arrow coming off of every domain thing? Yes. It doesn't matter that they go to the same one. Okay? As long as there's only one answer that goes with it, it's fine. This, yes, is a function. Notice how this one, what are you looking for? You're looking for two arrows coming off the same domain. It doesn't matter about the range. It doesn't matter if all of these went to the same number in the range. It doesn't matter. Don't worry about what it looks like in a graph. You just have to know that's what it looks like. Whew. Now, because of that, okay, well, you should be able to look at just ordered pairs. Let's say I've got this set of ordered pairs, 3, 4, 2, 1, 3, 0, and 5, 6. If I asked you, just looking at those ordered pairs, if that would be a function or not,
Yes.
you should be able to look at it, but you could do it as a mapping. let's do it as a mapping. What are my x's? I have 2, 3, and 5 for my x's. 2 goes to 1, 3 goes to 4, and 3 goes to 0, and 5 goes to 6. Is this a function? No, it's a relation, but it's not a function because the 3 goes to 2 separate y values. Again, this is x and y, this is domain, this is range. Got that? It could be the other way around though. You could have two separate x's going to the same y, but it can't be this way. Is that what you're doing? Oh, let's see. Okay. I don't have any idea. Are you coming back?
Yes.
Oh, okay. Now, with that being said, Tyler, we go back to this. When we did this thing here, and we said this is not a function because of this, okay, there is a thing called on a graph, the vertical line test. Notice it doesn't say horizontal line, it says vertical lines. Grant, what is a vertical line? Right. The vertical line test says this, and we'll write it down in a minute. If you sit and draw as many, an infinite amount, and you don't have to do this because it should be plainly obvious to you. If you sit and go vertical line, vertical line, vertical line, vertical line, vertical line, vertical, 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 vertical. If you draw all those vertical lines in there, the vertical line test for a function says that no vertical line you draw can touch the graph of whatever you're graphing in more than one place. Which if you look at what I got, I did a bunch of them that touch. See, this is not a function because look, if you look at this vertical line, it goes through the graph of my thing there and there. The vertical line test would say this is not a function. Because that one vertical line, there's a bunch of them, you could just pick any of them, you should just be able to look at it and say, oh yeah, that's vertical line test. Another example, let's say I've got, here's my graph, here's my graph. If you had a line that went like this, function or no function?
Function.
Right, because if I sat there and did a whole bunch of vertical lines, where in the world, every vertical line crosses it in only one place. If I had this as my graph, function or not a function?
Not a function.
Not a function simply because you take one vertical line and go right there and it crosses it not only in 1, 2, but also in 3 places there. And then, not to confuse you anymore, okay, generally speaking, when we've seen linear equations and other equations before, we've seen it like this: y equals 3x plus 2, right? This was our, what form was that? Slope-intercept form. If you are to write this in function form, or in functional notation, okay, if you write it in functional notation, please don't overcomplicate this. The only thing you do is you don't write the y, you just change it to this, the letter f and x, and everything else stays the same. And when you would say this, here's your upper level mathematics, you would say the function of x, or f of x, either way, equals 3x plus 2. But it's done the same thing, and it really means the same thing as y. Don't ask me why we do this, just understand that people do this. It's one of those where understand it now, see it later, forget it sometime. But if they say write it in functional notation, you put in the f of x, boom, boom. And you're just substituting numbers in for x, just like you always do. Will that be a function if I graph that? Sure will. What is it? It's just a straight line, right? Crosses the y-axis at 2, has a slope of 3. Looks like this. Is that a function?
Yeah, you did that so fast.
Yes, I did do that fast because it doesn't matter. Now, humor me and look at page 149, will you? Now what?
Can I give our book?
Yes.
I forgot it.
Page 149, looking at the practice there. Practice A says, give the domain and the range of the relation. How would you do that? Well, this is all it would be. Again, don't overthink this. People just get confused in all the words. The domain, you would write the letter D, stands for domain. Domain is going to be a set of numbers. The domain is all of the x numbers in the ordered pairs. So what are the x numbers, Jacob?
1, 2, 4, 8, 7, 3.
Probably I should have put them in order, but that is the domain. Domain are all the x numbers. The range would be all of the y numbers, which would be, what are the y numbers in those ordered pairs? Page 149. Abram, what are they? What?
Okay.
Abram, what are the y numbers in letter A? All the y.
2, 1, 6, 5, 7.
5, 7, 1? 10. And that would just be given the domain and the range. Domain are the x numbers, range are the y numbers. Letter B, use a diagram to determine whether the ordered pairs represent a function. That would be this. We call that mapping. What are the x numbers? Well, it looks like the x numbers are what? 5, 11, 12, 14, 13, and 14. 5, 11, 12, 13, 14, and then you have to say, what does 5 go to? 5 goes to what?
5.
5. 11 goes to
12.
12 goes to
1.
13 goes to
7.
and 14 goes to
10.
That is what the mapping of that would look like, or whatever they said, diagram. Wait. Yeah. No. Yeah. Yes. Does it represent a function? Yes or no?
Yes.
Yes. The only way you don't get a function is if one of these goes to two separate ranges. Letter C. Does y equals 3x minus 1 represent a function? And how would you know? Yes or no?
No. Yes.
Yeah. Well, there's
No.
two ways. There's two ways you can figure out something's a function. You could graph it and see if you get more than one value coming from every x, or you could put a table, or you could graph it. If I graph this, what do I get? Crosses at -1 has a slope of 3. 1, 2, 3 over 1. 1, 2, 3 over 1. With the vertical line test, is that going to pass the vertical line test? Ultimate,
Yes.
it is a function. Letter D. How about letter D? Does it represent a function? Yes or no?
No.
Westfall, does letter D represent a function? Yes or no?
No,
Why not?
because there's two negatives. That doesn't make sense.
Has nothing to do with negatives or positives. Why is letter D not a function, Amelia?
Because there's two zeros going
And-
to two different things.
Right. Two x values, two domains, or one domain goes to two different y values. 0 goes to 0 and 0 goes to 6. If you were graphing it out in a mapping, it would look like such. The x numbers are what? 0, -1, 0, -2, -1, 0, and 1. -2 goes to 6. -1 goes to 3. 0 goes to 0 and to 6. And this cannot happen. You cannot get that. What about letter E? A brochure costs 7 cents per page to print. Write a rule in functional notation that represents the cost of printing C copies. Well, how much does a copy cost? 7 cents. So you know you're going to take 7 cents times every copy. And in functional notation, it would just be this. Instead of whatever number on this side, the function of x equals this. Wow, congratulations. What about letter F? An author writes 30 pages per day. Write a function rule that the author can find out how many pages she has left to write before reaching 400 pages. Wow. Anybody got that one? Alton Burns, what are you thinking? Now, what I will tell you again, if you have no idea what equation will give you that, pick a number for what you don't know. For example, if an author writes 30 pages per day, what if she worked for 10 days? How many pages would she write?
300,
So how many pages would she have left?
100,
How did you figure that out? What did you do to get that?
subtraction.
Well, but first you did, how did you figure out how did 300?
I multiplied.
You took 30 times
days,
the number of days, and that answer you did what to it?
subtracted it
From 400. So here is your equation, 400 minus 9. To make it in functional notation, you just do this. Function of x equals 40 minus 30 times days. And that is it, ladies and gentlemen. Goodbye, sayonara, have fun, see you later.